Hello, madam. Hello, Andy.
Yes, sir. You can start, sir.
Okay. Yes, Andy. Good morning, students. Last class, so we'll start with polymers concept, and a few polymers are completed. Now we'll start different types of classification part completed, polymers classification, and now we'll discuss the different types of polymers. First is the polythene. Polythene is again, what is the preparation method? CH2 double bond CH2. It is ethene molecule. N number of ethene molecules at 1500 degrees Celsius almost in presence of oxygen or peroxide catalyst involved in polymerization process, and what is the compound formed here is polythene. This is called as a polythene. Polythene is formed in this reaction. Next, here we maintain high pressure again, high pressure, and this is called as a low density polythene. In these conditions, high pressure, high temperature conditions, we get what is that low density polythene, and in presence of catalyst triethyl aluminate plus titanium tetrachloride. What is this catalyst? It is called as a Ziegler-Natta catalyst. This is called a Ziegler-Natta catalyst, and here we maintain normal temperature conditions, more than 380 Kelvin temperature. And what is the polymer we get here? In this case, we get high density polythene. So these are preparation methods of low density polythene and high density polythene. So what are the uses of low density polythene? Low density polythene is transparent in nature. High density polythene is translucent in nature. So what is that? It is used in carry bags, and also it is used in squeeze bottles, insulation of electric wires also. Insulation of electric wires also used, and high density polythene used in what is that? Buckets, mugs, dustbins, toys. In this high density polythene used. This is example for additional polymerization. Next polymer is polyvinyl chloride, PVC, or it is called as a polyvinyl chloride. So it is a polymer of vinyl chloride, CH2CHCl. This is called as a vinyl chloride. N number of molecules involved in polymerization. What is this? We get a polyvinyl chloride. It is resistant to water. So mainly PVC used in pipes, water pipes, handbags, raincoats, and it is also used in insulation of electric wires. insulation of electric wires, polyvinyl chloride is used. Next is polytetrafluoroethylene. It is also called as a Teflon. N number of tetrafluoroethylene molecules involved in polymerization process. What is this? We get it Teflon. Teflon is does not react with vegetable oils and acids, bases. It does not involve in a reaction. So due to this, where it is used, Teflon is used in what is that non-stick what is that vessels or utensils. It is used, and also it is used in installation process. Also, Teflon is used. In this blankets also it is used. These are the important uses of Teflon. Next is polystyrene. What is the styrene molecule? Benzene molecule with a CH double bond CH2. N number involved in polymerization. We get polystyrene. This is we get here polystyrene. Where it is used, polystyrene mainly used in egg trays, molded cups, carpets. So this polystyrene is used. Molded cups and also hot drink cups also. This polystyrene is used. And the next important polymer is Novolac. Novolac is a linear polymer of phenol and the formaldehyde, both involved in linear polymerization. OCH2, SCH2, it is involved in linear polymerization. So because of this linear polymerization, polymer is formed, that is called as a Novolac. What is the use of Novolac? It is mainly used in paint industry, and it is used in construction industry also. Novolac is used. Paint and construction industry. And this is a linear polymer. If you add excess of formaldehyde, use excess of formaldehyde, then we get bakelite. So bakelite here is three-dimensional polymerization is possible in bakelite. Three-dimensional polymerization, and it is example for the cross-linked three-dimensional polymerization. We use excess of formaldehyde and bakelite. Bakelite is used in electric goods. It is used in electric goods. What is it? Because it withstands at high temperature and pressure conditions. Okay, so it is used in electric goods. Switchboards also it is used. It is example for thermocycling polymer, bakelite. And the preparation method is condensation method. Next, polymethyl methacrylate. What is this? This is called as a, what is this? COO. This is called as a, what is this? Polymethyl acrylate. If n number of molecules involved in and addition polymerization, we get CH2CCH3 COO CH3, n number of molecules involved in polymerization, n number. So what is this number? We get a polymethyl methacrylate. What is use of this polymer? It is used in, main use is solar panels. So polymethyl methacrylate is used in solar panels, main use. Next, polyacrylonitrates are called PAN. So vinyl cyanide, n number of molecules, okay, n number of molecules involved in polymerization reaction. What is that? We get CH2CHCN. This is called as the PAN or polyacrylonitrile. Where this polyacrylonitrile it is used in, what is that? The carpets, and it is used in blankets. This polyacrylonitrile is used now. Next polymer is nylon. Okay. Nylon 66. What are moreover units of nylon 66? Hexamethylene diamine, n number of molecules plus adipic acid. What is adipic acid? CH24COOH. Okay, NCOOH. Adipic acid, COOH. Here, COOH. CH24COOH. N number involved in polymerization. So we get NH, CH26, NH, CO, CH24, CO. N number of molecules involved in polymerization. This is nylon 66. And next is nylon 6. Okay. Nylon 66 monomer unit is caprolactam. What is this caprolactam? CH25, NH, CO. N number of molecules involved. You get what is that? Nylon 6. So nylon 66 and nylon 6. These are example for which also called as the polyamides also. Okay, and what is the use of this nylon 66 and nylon 6? It is used in innerwear, and the next it is used in what is that? Car tires. Car tires also it is used. Insulation also it is used. High tensile strength this polymer shows in threads of parachutes also. This nylon 66 is used, and the toothbrush also bristles of toothbrushes also. Okay, this nylon 6 and nylon 66 used, And then nylon 6 is used in carpets also. Next, phthalic acid, terephthalic acid plus formaldehyde. Okay. Both involved in polymerization, n number of molecules. This is called as the dacron, or it is also called as the mylar. Dacron or mylar. What is the uses of this dacron or mylar? It is used in again mixed with carpets. It is used in blankets, carpets, blankets, rugs, and mylar is used in preparation of magnetic tape recordings also. Mylar is used. Next, phthalic acid, n number of molecules involved in polymerization with the glycol, ethylene glycol, n number. What is the we get? Glyptol, or it is also called alkyde resin. You can call the glyptol or alkyde resin that polymer is formed. Okay, what is the use of glyptol or alkyde resin? It is used in cement industry and also paint industry. That is not important use of glyptol or alkyde resin. Next polymer is polyvinyl acetate. What is this vinyl acetate? CH2 double bond CHCO OCH3. So polyvinyl acetate, n number involved in polymerization process. It is used mainly in paint industry. Mainly used in paint industry, and also it is used in adhesives also. Polyvinyl acetate. Next is sarin. Vinyl chloride. What is the combination? It is a combination of vinyl chloride plus vinylidene chloride. What is this vinyl chloride? CH2 double bond CHCl. Vinylidene plus n number of CH2 double bond CCl. Vinylidene dichloride also we can call. Okay, this is called as a sarin. What is that? Wrapping of food, storage of food, or wrapping of food, storage or wrapping of food. Use this sarin or sarin. What is the combination? It is a combination of vinyl and vinylidene chloride. Sarin is a combination of vinyl and vinylidene chloride. Okay. Next is urea. Urea formaldehyde resin. Urea formaldehyde resin is the next polymer. What is it? Is a urea, n number of urea molecules plus n number of formaldehyde, both are combined to form urea formaldehyde resin. It is used in what is that? Glazed tiles. Glazed tiles, unbreakable cups. Okay, these are the main uses of this urea formaldehyde resins and surgical items also. Surgical items also. This urea formaldehyde resin is used. Next, melamine formaldehyde resin. Melamine formaldehyde resin. What is this melamine? And 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 NH2, 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 alternate bonds, n number, melamine, n number of formaldehyde combined to form melamine formaldehyde resin, NH2, N, 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 NH2, N, NH2. Carbon, here N is there. With this side, CH2 group, this side also CH2 group, this side also CH2 group. Is example for, what is the name? It is example for three-dimensional thermostatic polymer. It withstands with high temperature and pressure conditions. So it is used as a handles of utensils, unbreakable cups, polymers. For important polymers, this is the what is the topic of polymers. And next, Okay. So here, different types here solutions are there. Solid solution, solvent is solid. Liquid solution, solvent is liquid. Gaseous solution, solvent is gas. So what are example for solid solutions? Example, alloys. Alloys the example for both solute and solid in liquid state. Amalgam. Alloys and we take example, hydrogen is hydrogen occluded in palladium metal. That is a gas in solid type of solution. Two examples. Here, solid in liquid type. Aerated drinks. Aerated drinks. What is the nature of this liquid solution? In this, carbon dioxide present in water. One example. Alcohol plus water is also an example for liquid solutions. Okay. And metal with mercury, these are called amalgam. This is example for solid and liquid type of solutions. Gaseous solutions, what is the gaseous solution? Mixture of gases present in air. This is a what is a gas in gas type of solution. So these are few different types of solutions. So based on physical state of solute and solvent. Next, here in the intermediate or entrance level, solid in liquid type of solutions important, and solid in gas type of solutions also important. So next important concept is concentration. What is meaning of concentration of solution? So concentration means how much amount of solute present in given amount of solvent, that is called as a concentration of solution. So what is this concentration of solution explains? It explains about the amount of solute plus solvent in solution. So if you know concentration, known concentration, solutions are called as a, what is the nature of this solution? We can call it as a standard solutions. If you know concentration of solution, that is called as a standard solutions, where this standard solutions, generally used in chemical laboratories and chemical industries. Known concentration, or we can call it as a standard solutions are used. And how to prepare standard solutions? Some concentration methods are there. Some methods are there. These are called concentration methods. So what are these different concentration methods? One is called as a molarity. Second is called as a molality. Third is called as a mole fraction. Fourth is called as a normality. Fifth is called as a, what is that, weight by weight percentage method. Sixth is called as a weight by volume percentage method. Seventh is called as a volume by volume percentage method. Eighth is called as a ppm method. So these are different methods are used to prepare standard solutions. What are the methods? Molality, mole fraction, normality, weight by weight percentage method, weight by volume percentage method, volume by volume percentage method, and ppm method. First we start with the molarity. Molarity is the number of moles of solute present in, it is that 1 liter of solvent, that is called as a molarity. So N is the number of moles of solute and P is the volume of solution in liters. What are the units of molarity? Moles per liter. Moles per liter is the units of molarity. We write a formula. We know that number of moles is equal to weight of solute by gram molecular weight of solute into 1000 by 1 by volume in liters, or weight of solute by gram molecular weight of solute into 1000 by volume of solution in milliliters. We use this formula, general formula, or molarity is equal to, here when it is related to weight by weight percentage method, weight by weight percentage method means weight by weight percent. One example, weight by weight percent of solute is equal to, what is the formula? Weight of solute by gram molecular weight of solution into 100. Okay, so 20% weight by weight percentage of NaOH, what it indicates, 20 grams of NaOH present in 100 grams of water. 20% NaOH weight by weight percentage is the 20 grams of NaOH in 100 grams of water. So here, instead of weight of solute, we use weight by weight percentage of solute. Here, weight by weight percentage, given amount of solute, instead we can take weight by weight percentage of solute by gram molecular weight of solute into 1000 by 100. What is the volume of solution? That is equal to 100. We use this formula, or we use one more formula. What is that? Molarity is equal to weight by weight percent of solutes. Okay. So by gram molecular weight of solutes into 10 into density. Use this formula also. Okay. So find out molarity of solution. Okay. Next is molarity is inversely proportional to volume. If solution is diluted, molarity always decreases. So, what is the next is dilution law? When excess of water is added, molarity of solution decreases. So, your molarity is equal to, according to dilution law, molarity is M1. Initial molarity, initial volume is equal to M2 V2. V1 is the initial volume, V2 is the final volume, and M2 is the final molarity. Water, amount of water added to increase dilution. Amount of water added. Amount of water added is equal to V2 minus V1. We use this formula. Okay. It is dilution law. Next, in case of neutralization reaction. Okay, acid base will involved. What is the formula we used? M1 V1 by M1 is equal to M2 V2 by M2. For neutralization reaction, we use this formula. M1 V1, this is acid. It is the base. How many moles of acid or base involved in balanced chemical reaction? We use this formula. And the next is, what is the molarity of mixture of acids? Okay, how to find out? M1 V1 plus M2 V2 plus so on. Initial molarity, initial volume, M2 V2, second acid molarity and volume, so on, by total volume of solution. Next, molarity of mixture of acids and bases. When acids and bases present in a mixture, Which formula is used? Acids and bases present in a mixture. Molarity, what is the formula? If the concentration of acid is more, then molarity of mixture is equal to N by molarity and volume of acid minus molarity and volume of base by total volume. H plus ions greater than OH minus ions, we use this formula. Okay, and one more case. If OH minus ion greater than H plus ions, what is the formula used? Molarity and volume of base minus molarity of volume of acid by total volume. We use this formula for molarity of acids and bases. So these are different formulas used in what is that molarity concept. We discussed few problems on this molarity. Calculate molarity of 2 grams of NaOH in 100 ml of water. Okay. Weight of solute is given. 2 grams of NaOH. So molarity is equal to weight of NaOH 2, molecular weight of NaOH 23 plus 16 plus 1, that is equal to 40. By 40 into 1000 by 100. What is the value we get? 0.5. Next, calculate molarity of 10% of H2SO4. 10% of NaOH. Okay. What is this percentage? What it indicates? Weight by volume. 10% indicates weight by volume. So in this case, molarity is equal to use formula weight by volume percentage by molecular weight of solutes into 1000 by 100, or we can take it as a, you divide this and we get what is number? Weight by volume percent into 10 by molecular weight of solutes. Okay. Molecular weight of solutes. So here 10% molarity is equal to 10 means 10 by 40 into 1000, 1000 by 100. What is the value we get? 100 by 40? 2.5. What is molarity of solution? That is equal to 2.5 is the molarity of a solution. Okay. And next, calculate molarity of 10% weight by weight of NaOH with density 20 gram per cubic centimeter. Find out the molarity of 10% weight, 10% weight by weight percentage of sodium hydroxide with density 20 grams per cubic centimeters. Molarity is equal to, formula is weight by weight percentage into density into, what is that, 10 by molecular weight of solutes. This is the formula we use. Weight by weight percentage is 10, density is equal to 20 into 10 by 40. What is this we get here? 2000 by 40, 50. What is polarity of solution is 50. Next, 20 grams of 100 ml of NaOH is neutralized with 4.9 grams of 100 ml of H2SO4. Okay. Calculate molarity of mixture. Whenever neutralization reaction is given, use this formula. F1 V1 by N1 is equal to F2 V2 by N2. And the ml of H2SO4. Calculates. Question is calculates molarity of H2SO4. Okay. First we find out molarity of base. What is molarity of base? 20 given weight by 40 into 1000 by 100. We get 5. Volume of NaOH is equal to 100. But we don't know molarity of H2SO4. We don't know. Volume of H2SO4 100. Number of moles also you find out from balanced chemical reaction. What is this balanced chemical reaction of NaOH and H2SO4? 2 moles of NaOH reacts with H2SO4. You get Na2SO4 plus 2H2O. So this is N is equal to 2, N is equal to 1 here. Okay. So now find out this mixture molarity. Find out molarity of H2SO4. M1 is the M1 V1 here, M2 V2 here. M1 is equal to, what is the molarity is 0.5. 0.5 into volume is equal to 100. How many moles of NaOH is used? By 2 is equal to, we don't know molarity of H2SO4. Molarity of H2SO4 into volume is equal to 100 by 1 mole is used. So we can find out the molarity of H2SO4. Molarity of H2SO4 is equal to 0.5 into 100 by 100 into 2. So 100 cancel. That is what we can write here now. 5 into 10 to the power of minus 1 by 2. 2.5. What is that now? We get a 0.25 molarity of H2SO4. So this is the molarity in case of neutralization reactions. Next question. 2 molarity of 100 ml HCl mixed with 2 molarity of 200 ml H2SO4 and 1 molarity of 100 ml HNO3. Okay. Calculates molarity of mixture. Calculate molarity of the mixture. So all our acids are given. So molarity of mixture is equal to, we know that M1V1 is equal as M2V2. You can take it as M1V1. You can take it as M2V2. You can take it as M3V3. What is the molarity of mixture? M1V1 2 into 100 plus M2V2 plus 2 into 200 plus M3V3 plus 100 into 1 by total volume is 500. So 200 plus 400 plus 100 by 500. What is the value we get now? 800 by 500 or 8 by 5. 8 ones are 1.6. What is the molarity of mixture of acids, that is 1.6 we get. Okay. If an acid and base present in a mixture, then how to find out acid and base present in a mixture? Calculate molarity of mixture. What it contains? It contains 20 grams of 100 ml NaOH and 4.9 grams of 98 grams of 100 ml H2SO4. Okay. So first we find out this molarity. Molarity of NaOH 20 by 40 into 1000 by 100. What is the molarity? We get 5. So in the same way you find out molarity of H2SO4. H2SO4 98 by, what is the molecular weight of H2SO4? H2SO4 also 98 molecular weights. Hydrogen atomic weight 1, sulfur 32, oxygen 16. So molecular weight is 98. 98 into 1000 by 100. What is the molarity here? 10. So which is higher? Acid is higher. So molarity of mixture is equal to 10 minus 5 by, what is the total volume? 200. 5 by 200. Or we can write here 5 by 20 into 10 to the power of minus 1 is a 4. 1 by 4 into 10 to the power of minus 1. 10 into 10 to the power of minus 2 by 4. 2.5. 0.025. What is the molarity of mixture of acid and base is 0.025. Yeah. So this is the way to find out the molarity of what is that, acids and bases. Okay. And I'll discuss about normality. One more important concept is normality. So, what is normality? Normality, what it indicates? Number of gram equivalents of solute by volume of solution in a liters. This is called as a normality. Number of gram equivalents, that is important. We can extend the formula. What is the given weight of a solute by equivalent weight of a solute into 1000 by volume in milliliters. Okay. In the liters, we can write volume in milliliters. First is how to find out equivalent weight. In case of acids, molecular weight of acid by basicity of acid. What is basicity? How many hydrogens are displaced by acid? That is called as a basicity of acid. We take example H2SO4. So these hydrogens are attached to oxygen, can be displaced. So basicity 2. Acetic acid, hydrogen attached to more electronegative oxygen can be displaced. So basicity 1. So now we write we discuss how some acids basicity. Here basicity, sulfuric acid 2, phosphoric acid 3, phosphorus acid 2, acetic acid 1. Okay, important acids basicity. Okay, if you write normality, equivalent weight of example H2SO4. The 98 is a molecular weight, basicity is 2. So 98 is divided by 2, then we get the equivalent weight of H2SO4, that is equal to 49. Okay. So this is a method to find out what is that base with equivalent weight of acids, equivalent weight of bases, molecular weight of a base by how many hydroxyl ions were displaced. That is the equivalent weight of bases. This is the method to find out. Okay. If you take example NaOH, in case of equivalent weight of NaOH, molecular weight of NaOH is 40 by OH is 40. Equivalent weight of calcium hydroxide. Calcium hydroxide. What is this? You find out the molecular weight of calcium hydroxide. Calcium 40. Here oxygen 60. 2 oxygen 32. 2 hydrogens 2. So 74. 74 by 2 hydroxyl ions are present by 2. 2 3 is 6. 2 37. So this is the method to find out equivalent weight of bases. Next, equivalent weight of salts. Salt is example. Salt is not a molecule, so instead of molecular weight, we write a formula weight by total number of positive or negative charges. This is equivalent weight of salt. What is the formula weight of salt? Formula weight. We take an example, sodium carbonate. Here. Sodium carbonate, what is equivalent weight? Sodium 23 plus carbon 12 plus 3 into 60, that is equal to 106. So equivalent weight is equal to 106 by, what is the charge of carbonate? Carbonate charge is -2, or you can write each sodium charge is +1. So right here 2 total positive or negative charges. What is equivalent weight is 53. So this is the method to find out the equivalent weight of salt. And in a neutralization reaction, imagine MnO4 -1 converted into MnO2. In redox reactions, what is equivalent weight? Equivalent weight is equal to molecular weight of MnO4, molecular weight of MnO4, or if you write Mn, we want to find out Mn by what is oxidation state? It is +7, it is +4, change is equal to 3. This is the method to find out equivalent weight in case of salts. Okay. So this is here instead of molecular weight in normality, we use equivalent weight. What are different formulae based on normality? Normality is equal to given weight by equivalent weight. What is this? It is for solute into 1000 by volume of solution in milliliters. One more formula, dilution law. When diluted, normality decreases. N1 V1 is equal to N2 V2. This is called dilution law. Next is normality of mixture of acids or bases. What is the formula? Normality of mixture of acids or bases. N1 given N2 V2 so on by total volume. Next, normality of, next concept is normality of mixture of acid and base. Acid and base is equal to N1 V1 minus N2 V2 by total volume. N1 V1, what it indicates there? Higher values present, that is maybe acid or base, that is N1, and remaining is N2 V2 by total volume is V. And normality is equal to weight by weight percentage into density into 10 by equivalent weight. Equivalent weight of solute. Here, use this different formula to find out normality. And we discuss the remaining topics in next Next class, concentration methods and solutions.